Let's look at absolute value inequalities, specifically the general forms for absolute value inequalities. For example, if I gave you the absolute value of AX plus B is less than C. Believe it or not, this actually relates to the AND type of compound inequalities. Remember that from a previous lesson where we had AND or inequalities. So this relates to AND. What makes it relates is the symbol. The less than symbol relates to AND, while the opposite, greater than symbol, relates to OR. So if I was to give you example number 1, the absolute value of 2x plus 1 is less than 5. 2x plus 1 is less than 5. So really what you're going to do in this problem is you're going to rewrite this problem because it's a less than problem. It's an AND problem. I'm going to rewrite this problem. So first thing I do to rewrite it is drop the absolute symbols, absolute values. So I'm going to rewrite it with 2x plus 1 is less than 5. But then I take this same symbol, I put it in the front, and then instead of 5, I'm going to write negative 5. Now it has become a compound inequality, an AND problem more specifically. I have to solve it like normal. Subtract 1 from all sides. So then you're left with negative 6 is less than 2x is less than 4. Divide everything by 2. Divide everything by 2. And when you do that, the 2's cancel in the center because our goal was to get that x by itself. And then you're left with negative 3 is less than x is less than 2. So 2 is greater than negative 3 and less than 2. So that's basically how that goes. Let's try it again this time. We're going to try it this time with a whole nother symbol. So let's rewrite the problem, or let's write a problem, excuse me. The absolute value of 2x plus 4 is greater than or less than 6. The absolute value of 2x plus 4 is greater than or less than 6. Notice the symbol has changed here. The symbol has changed, so now we're no longer talking about AND, we're talking about OR. So let's rewrite the problem starting off by dropping the absolute value symbols. So 2x plus 4 is greater than or equal to 6, or 2x plus 4, flip the sign, less than or equal to negative 6. That's the biggest difference between AND and OR. When it's an OR problem, you are going to change the inequality symbol and flip the sign of the number to the right of that symbol. Once you do that, you've set it up perfectly, and now we're just going to solve. We're starting it off by subtracting 4 from both sides. So then you're left with 2x is greater than or equal to 2. Divide by 2. And you're left with x is greater than or equal to 1. Don't forget to write the OR symbol. I know that's minor, but I always tell my students that. Subtract 4 from both sides. You're left with 2x is less than or equal to negative 10. Divide by 2. And x is less than or equal to negative 5. So in this problem, the final answer is x is greater than or equal to 1, or x is less than or equal to negative 5. If you remember from the previous section when you're graphing AND and OR problems, if it's an AND problem, you graph going into each other. If it's an OR problem, you always graph, or the graph should be going away from each other once you shade. Make sure you remember that. AND goes in, OR goes away. Remember, open circle versus a closed circle. Look at your symbols. If there is a line under the symbol, that means it's going to be a closed circle. If there is no line, such as with greater than or less than, it'll be an open circle.